Now we're going to talk about something called internuclear ophthalmoplegia, which I will refer to as INO for the rest of these slides. So an INO is a clinical syndrome that's the result of damage to one or both of the medial longitudinal fasciculi, or the MLF. So these medial longitudinal fasciculi are tracts that run from the cranial nerve 6 nuclei, or the lateral abducens nerve nuclei, to the contralateral medial rectus subnucleus of cranial nerve 3, which is the oculomotor nerve. So these are tracts that run from CN6 nuclei to CN3 nuclei, and the purpose is to coordinate lateral eye movements. So when your left eye abducts via the cranial nerve 6, causing firing of the lateral rectus of the left eye, you need your right eye to adduct and move with that left eye. So the right eye has to adduct via cranial nerve 3, sending signals to the medial rectus of the right eye. And the signal to do that comes from the right medial longitudinal fasciculus. So now I'll do an illustration to show how the medial longitudinal fasciculi work. So down here you have the nuclei of cranial nerve 6, or the lateral abducens nuclei. So this is the left lateral abducens nuclei, and this one's the right. So I'll just call that CN6 nuclei. And these are each going to send signals to their respective lateral rectus muscle to abduct that eye. So the right CN6 nuclei will send its signal to the right lateral rectus muscle, and that'll, when stimulated, abduct the right eye. And the left one will do the same for the left eye. It'll send signal to the left lateral rectus muscle to, when stimulated, abduct the left eye. Now, the CN6 nuclei also has another projection called the medial longitudinal fasciculus. And the projection from the left eye, or from the left CN6 nuclei, goes to the right, what's called the medial rectus nucleus of CN3. So when the left CN6 nuclei is activated, it not only just activates the lateral rectus of the left eye to abduct the left eye, it also sends a signal to the medial rectus nucleus of cranial nerve 3, which sends signal to the medial rectus of the right eye to adduct that right eye. So every time the left eye abducts, the right eye adducts and goes with it. And the right cranial nerve 6 nuclei sends a medial longitudinal fasciculus to the left medial rectus nucleus of cranial nerve 3 to do the same thing. So this will go to the medial rectus of the left eye, and every time the right cranial nerve 6 nuclei is stimulated, it'll not only activate the lateral rectus of the right eye to abduct the right eye, it'll also send signal through the left medial longitudinal fasciculus to the left medial rectus nucleus of cranial nerve 3 and activate the left medial rectus to adduct the left eye and move it along with the right eye. So I just wanted to clarify that the tract going from the cranial nerve 6 nucleus, or the left cranial nerve 6 nucleus, to the right medial rectus nucleus of CN3, that's going to be called the right MLF, or the right medial longitudinal fasciculus, because it's crossing over to the right side. So that's the right MLF. And then the medial longitudinal fasciculus that connects the right CN6 nucleus with the left medial rectus nucleus of cranial nerve 3, that's going to be called the left medial longitudinal fasciculus. And that's important just based on naming. So if you have damage to the right medial longitudinal fasciculus, we call that a right INO, because a right INO happens, and the clinical syndrome is that if you have a right INO, you're unable to adduct your right eye when your left eye abducts, and that's because you have damage to the right medial longitudinal fasciculus. So basically your left cranial nerve 6 nucleus is firing, and that's stimulating firing of your left lateral rectus to abduct your left eye. But you have damage to this right medial longitudinal fasciculus, so no signal is getting through to the right medial rectus nucleus of CN3, and so you're not going to be firing that medial rectus of the right eye. So while your left eye abducts, your right eye stays in the same position, and that's called a right INO, which is caused by damage to the right medial longitudinal fasciculus. So INOs are important clinically because the medial longitudinal fasciculi are tracts that are highly myelinated. And so patients that have the disease multiple sclerosis, which causes them to develop demyelinating lesions, often the medial longitudinal fasciculi are the first affected. And so their presenting symptom might be a right INO or a left INO or a bilateral INO. And that's why this is important. So, like we said before in the previous slide, a right INO refers to a right medial longitudinal fasciculus lesion. And the right eye is paralyzed in that case when the left eye abducts. What I failed to mention before is that when this happens, the left eye actually gets nystagmus. So when your left eye is trying to abduct and your right eye is staying in the same position, your left eye has nystagmus.